Good morning. I just want to do a quick walkthrough of the notes for all my quarantine students who are out there. This is section 6.1 and 6.3 in your textbook, and it's basically section 4.3 for the College Board units. All right. So when we're talking about probability, there's some vocabulary you need to know. I've got my little game of rock, paper, scissors up here in the corner to kind of try to symbolize this. So a random process is one where your results happen by chance. And so anytime that I'm, shuffling up cards and pulling out a card or rolling a die or flipping a coin, it's called a random process. I don't know what the result is going to be. A lot of times if I interview people, that's another kind of random process, because when I go to ask them the question, I don't know what the result is going to be. And so we have this thing called a chance experiment. Any activity or situation where there's some sort of uncertainty about what will happen as the result. So for example, I've got two individuals and they're going to choose rock, paper, or scissors. And so I don't know what's going to happen before they do that. So that's my example of a chance experiment. The sample space is the collection of all possible outcomes. So when you hear the word sample space, is basically everything that could possibly come out of this. And an outcome would be a single trial, what would happen one time. So all the possible things. So for example, you could have both people have rock, you could have rock and paper, you could have paper and rock, right? So depending on the order, that order would matter depending on who would win. So it does matter in that case. So I've got rock, 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 paper, rock, scissors, etc. These are all my possible outcomes. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 possible elements in the sample space. And an event is basically anything you would do that would count. It's sort of like a subset of these, of the sample space. So it's some sort of collection of outcomes that we might be interested in. For example, what are all the possible outcomes where player one shows rock? So that would be rock, 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 paper, rock, scissors. And if you ever heard the word simple event, a simple event is any sort of outcome where there is really only one chance. So when we go to talk about probability, the probability of a simple event is always 1 over something. So for example, both players showing rock, there's only one possible outcome out of all 9 where that happens. So when we're talking about probability, we usually need to know how many things are in the sample space, and then we also need to know how many things are in the outcome of our event. So for example, the probability that player one shows rock is going to be 3 out of 9. And the probability that both players show rocks is 1 out of 9. So that's how we discuss probability. And remember, probability, that's we're talking about the likelihood of the event, and usually that's interpreted as a relative frequency. So this means that if we were to repeat this rock, paper, scissors event over and over and over and over again, we would estimate that about 1 out of 9, or about 11% of the time, that player one would show rock if this was truly random independent events. Okay. Now, a couple of words that you need to know that you should be familiar with from previous courses, but let's just do a little review, is that the words not, and or. All right, so when we talk about not A or not event A, that can be used with a little, there's like a little A with an exponent C. You can have an apostrophe, or sometimes it has a bar depending on which sort of textbook you're looking at. But all of these mean the complement. This is everything that is not A. So for example, if they're talking about the event that player one wins, all the different outcomes where player one wins, the complement of that event is all the ones where player one does not win. And it's important to notice the difference. There's a difference between not winning and losing, because you could also have ties in this case. So the complement is everything that's not a win. Okay, so visually what we look at, if all the A's are inside my little Venn diagram here, the not A would be everything on the outside. And again, anytime you see any of these symbols, you're looking for the not, the opposite. One interesting thing about complements is that they add up to 100%. So to find the complement of an event, it's the rest of that 100%, 1 minus the probability of the event. So if I told you there's a 30% chance that it's going to rain tomorrow, we would interpret that as a 70% chance that it's not going to rain. And those should add up to 100. Our other two special words are and or. And one thing that might be a little different about AP Stat is that you're going to have to know this symbol for them. So the word and, we have this symbol called the intersection. It kind of looks like an upside down U. This intersection symbol means and. You can kind of look like if you were going to draw kind of a fancy A, that would almost look like sort of a fancy A. It's just missing its little stick, its little bar. It means the overlap, the outcomes that are in both there. So for example, if I'm talking about what are the outcomes where player one wins and they play rock, player one wins and they play rock, then there's 3 different outcomes where player one would win. But only one of those outcomes are they playing the rock, where player one plays rock and player two plays scissors. So I'm looking for the things that make both things true at the same time. If I tell you you have to have your passport and your driver's license, you have to have both pieces of documentation. Okay. The other is the word or, and one thing to remember is that or is usually more. Okay, there's more things included in an or, and it has this symbol called the union. It's when you're putting 2 groups of things together. The union is the letter U, so that's kind of, remember, that's a union. If you can remember, that's an and. So that's A and B, or anything else that happens to be in both of them. I just confused you, sorry about that. So this union here are the outcomes that are in least one of the events. Okay, so that means everything that's in A, everything's in B, and everything that happens to be in both. And sometimes this is called the joint probability. So for example, player one wins or player one plays rock. So the cases where player one wins would be rock, scissors, paper, rock, or scissors, paper. And the cases where they play rock are rock, scissors, rock, paper, and, oh, I wrote rock, scissors twice. Silly me. That would be rock, rock would be that last one. Okay, so a little error on my key there. Sorry about that. So these outcomes, we want to make sure we don't repeat anything. So we don't want to double count this middle. So we're going to have to be careful about that in a little bit. Okay. All right. Now, the other word that you need to know is something called mutually exclusive. Mutually exclusive, and sometimes they use the word disjoint, is when you have no outcomes in common. So if I have event A and event B, and they're literally nothing in common, then they would be called mutually exclusive. And mathematically, what that means is that the probability of A and B, the probability of getting an element in the overlap of those 2 events, is impossible. It's 0. It's not going to happen. If I was asked to prove mathematically that 2 events were mutually exclusive, I would word my argument like this. I would say, if A and B are mutually exclusive, then I would expect the probability of A and B to be 0. And then I would find the probability of A and B. I'd say the probability of A and B is this number. Maybe it's 0, maybe it's something else, like 23%. And then since the whatever you got here, I would say A and B are mutually exclusive or they're not. So if the probability was 0, I'd say, well, since I got the probability of 0, then they are mutually exclusive. But since the probability of A and B is 22%, then they're not. Okay, so this is kind of my argument. I would expect to see this. Here's what I actually see, and here's what that means. That's the mathematical argument for this. Okay, and this is something that you need to memorize. Anytime you see that word mutually exclusive, your brain needs to automatically think, okay, that means that the A and B probability is 0. Okay, and that's going to be helpful later. Now, a couple of other things that you're going to see on your formula sheet. Now, remember, you have that formula sheet. It should be green, should be in your stuff. We have the probability formulas that we're going to use in this chapter. There are 2 of them. They should be right under the word probability distributions. This is just a snip. And we will be using those both in this chapter, okay? So for any event, a couple things you have to know here. Fundamental properties of probability. First off, any probability has to be between 0 and 1. If I ask you the probability of something, I'm expecting an answer like 0.325 or 7/8 or something that represents a number between 0 and 1. If you're getting a negative number or a number bigger than 1, you are doing something wrong, okay? So any probability has to be expressed between 0 and 1. On the AP exam, it's generally acceptable to express your answer as a fraction or as a decimal. I would not give my answer as a percentage unless they asked for it in that way. It's not necessary. Okay. If S is the sample space, then the probability of the sample space is equal to 1. So the sample space literally has to include everything. That has to represent 100% of your values. Remember that your complements will add up to 100%. So if you need to find the probability of something and you don't know it, but you know what it isn't, you can subtract those. So if I know that the number of people who are not wearing red is 10%, then I know that the probability of people wearing red must be 90. Those Those things have to add up to 100%. When we're talking about the probability of A or B, remember that's the union, A or B. We want everything that's in A and everything that's in B and anything that happens to be in both. But the problem is that overlap then gets counted twice. So there's actually a formula you can use, or you can just kind of logic your way through. This is on the formula sheet. It's not need to be memorized, but you do need to know these symbols. So A or B, the probability of A or B is all the A's plus all the B's minus anything that happens to be in the overlap. Because the idea is if I have everything that's in A and everything that's in B, I've counted that overlap twice. And so by subtracting off the overlap one time, I haven't overcounted. Okay. The other thing that we need to know is the probability of A and B. Most of the time we're going to be looking at a table and we can just say that's the overlap. But there is another way to calculate an and we'll talk more about that later. So to put a pin in that for right now, we'll come back there. Okay. All right. Now, for example, you interview Mrs. Leahy's AP statistics classes and you ask them the following questions. Did you know there was going to be so much writing in this course? The sample space, they can either say yes, no, or maybe. Okay, and I want to know which of the following could be the probabilities. So if I wanted to verify of which things could actually be legitimate probabilities, I'm going to go through and check the following things. Do they add up to 100%, which is a requirement? And is each probability in the right range between 0 and 1? All right, so this first one, I've got 20% yes, 30% no, and 50% maybe. They add up to 1, and they're all between 0 and 1. That one's good. Here, 0.4, 0.5, and 0.2, those add up to 1.1. No good. This adds up to 110%. Not going to work for us for probabilities. So we can't say that this works. There's something going on here. This doesn't work for probability. 0, 1, and 0. Okay, that's totally fine. It adds up to 1. 0 means nobody said it, basically. The probability of getting someone who said that is impossible. And 100% of the people said no in this case. All right, so that's totally fine. They add up to 1. They're between 0 and 1 inclusive, so that's a yes. Here, I've got that 1.1 and I've got a negative 0.3. Automatically, that should fire off problems. All my probabilities have to be between 0 and 1. This one's too high, that one's too low, so we got to toss them out, even though they do add up to 100%. All right, so that one's no good. Also think about that in terms of finding probability, just like you have in previous classes. The local weather station shows that its weather predictions have been accurate 89 times in the past 120 days. Find the probability of getting a correct forecast. So that would be that it's accurate. So that would be 89 out of 120. And I'm going to tell you, you need to set up that fraction. Always. Always set up the probability fraction. Always. A lot of times if you don't have that fraction, you're not going to get full credit on the problem. That knocks you down from a 4 out of 4 to 3 out of 4 just for not having a fraction. Not worth getting a 75% on a question because you were too lazy to write down a fraction. Write it down. Also, that's good enough for an answer. You can leave it as 89 out of 120. But if you do it as a decimal, I would suggest you round to at least 3 decimal places. There's no rounding rules on the AP Stat exam. So unlike the AP Calculus where you have to have 3 decimal places, they can be truncated, they can be, we're just kind of like, whatever. Okay, but you should do at least 3 decimal places. Anything less than that is not going to be considered specific enough, and you're not going to be able to get enough detail out of that for the answers that we're going to need later. Okay, what's the probability of the incorrect forecast? So that's going to be the complement. So I'm just going to take 1 minus my answer from before, and I'm going to get 0.258. Now, again, I'm going to show this step, 1 minus 0.742, to show that I know that I'm using this idea of the complement. So I'm going to show that step. Even though we all know what you're doing, and you can do it in your calculator, you're still going to show that step because that proves you understand how the statistics work. Okay, if you don't show that, the best thing to do would be to do 120 minus 89, get that number, and set it up out of 120. All right. So working from a problem, so I have 190 students, 100 of them are seniors. Of the seniors, 60 are taking an AP course. Of the non-seniors, 40 are taking an AP course. If the student is selected at random, find the following probabilities. Now, my advice to you is anytime you have a bunch of numbers like this, you should consider trying to make a table. There's 2 things going on here. We have seniors and non-seniors, and we have AP and not AP. So that's what I filled in first. And then the other thing you always need is you need a row total and a column total. And you want to write that word total in there. That's going to be really important, that word total, because it implies that you did addition, and it saves you from having to actually add anything, okay? And show that step. All right, so I says you have 190 students, so that goes in the bottom corner. That's my grand total. 100 of them are seniors. That's the total number of seniors. Of the seniors, so only of the seniors, 60 are taking AP. Okay, so that means 40 must not be taking an AP test because they have to add up to 100. Of the non-seniors, 40 are taking an AP. And so what else can I figure out? Well, 60 plus 40 must be 100. So this number right below it has to be 90, and 40 plus 50 would be 90, and now I can fill in the rest of these spots. Okay, what's the probability of a non-senior then? That would be 90 out of 190. A senior and not taking the AP exam, I'm looking for the overlap. Who is in both of those groups? Somebody who's a senior and not taking, that's 40 out of 190. Taking the AP, that is going to be 100 out of 190. Not taking would be the 90 out of 190. And then what about a senior or taking the AP exam? So a senior, so there's 100 of those. And AP exam, there's 100 in those. But notice that 100 plus 100 adds up to 200. That's more than the number of people we interviewed. So you can't just put them together. It's all the A's plus all the B's. But you also have to subtract off the both because this overlap of 60 is being counted in both of those. So we're like 60 too high because it's being counted in the senior 100 and the AP 100. So 100 from the seniors, 100 taking AP minus the 60 that were in both groups. And that gives me 140 out of 190. So be careful with those ors. All right, have a couple of dice here. Okay, if you ever have a dice question, remember there are 36 possible outcomes. Okay, 6 ways to roll the first die, 6 ways to roll the second die, giving you 36 possible. Here's a little picture of those. I also have those on the wall in the classroom. You could Google those, etc. So what's the probability of a sum of 8? So again, we're going to find all the sums of 8. I've got them highlighted here, 5 out of 36. A sum of 7 or a sum of 11. There are 1, 2, 3, 4, 5, 6 that add up to 7 and 1, 2 that add up to 11. There's no overlap there, so I can just put those together. That's 8 outcomes total. And remember, if there's no overlap, the word for that is mutually exclusive or disjoint, either one of those. Not doubles. Now, there's a lot of things here that aren't doubles, but I knew there's 1, 2, 3, 4, 5, 6 that are. So if there are 6 that are, that means there are 30 that aren't. So 30 out of 36. What's the probability of a sum of 3 or doubles? Now again, my sums of 3 I've got in blue here. Doubles are in orange. There's no overlap, so I'm just going to count those up. 2 plus 6 gives me that 8. A sum greater than 10, I'm going to pick my 11s and my 12s down here. There's 3 of those. Or doubles, well, there are 6 doubles. But if I think 1, 2, 3, 4, 5, 6, okay, and then 1, 2, 3, okay, I'm counting that 12, 12, or that 12, 6, 6 combination twice. Okay, so I don't want that one on there. Another way to think about that is you want all the doubles, and then you want anything that's bigger than 10 that you haven't counted yet. Either way, you're going to get that 8. So 3 bigger than 10, 6 that are doubles, minus the 1 that's in both. All right, sum of 8 and doubles, that is an overlap. The only one that is in both of those groups is 4, 4, which gives you doubles and equal to 8. And then sum of 7 and doubles, none of my 7s are doubles, so that's 0. Don't be afraid to say that something has a probability of 0. It happens, okay? All right, so 0, that is disjoint. I wrote it as 0 out of 36, but I probably should have gone ahead and wrote equals 0 on that. Okay, now remember that mutually exclusive means that the probability of A and B is 0. Mutually exclusive, A and B equals 0. So I read this problem and it says, events A and B are mutually exclusive events. If the probability of A is 1/4 and the probability of A or B is 1/3, what is the probability of B? All right, there's a lot of stuff happening here. Almost any time where you have one of these problems where they're giving you ands and ors and probabilities, you should think, I wonder if this is a formula problem. So I go to my formula sheet and I know I have a formula that has the union. Remember, that's the or, and I know what or is. So I know the formula, probability of A or B is A plus B minus the and. Okay, so these or and then minus the and. And I know the 1/3. And I know the 1/4 because they told me. I don't know what the probability of B is. I'm looking for that. And because they told me these are mutually exclusive, I also know that the probability of A and B is equal to 0. Okay, so I'm able to fill into this formula everything in here except for the thing I'm looking for, which is B. And you should always show this step. If you're going to use a formula, you should show substitution into the formula. You don't need to write the generic one down with the symbols, okay? Just write where you've substituted everything in the right place, and then you can solve however it makes the most sense to you. I just put this into my calculator as and subtracted the 1/4, and I end up with 0.083 for my probability of B. All right. The number of customers served per hour at a small restaurant over 2 weeks. The results are recorded in the table. If a result is selected at random, what's the probability that it will be one of these numbers? So again, the first thing you need to do is verify, are all of my probabilities, see this P of X? Are all of these probabilities between 0 and 1? That's good. Do they add up to 1? Good. All right, so we're good to go there, which means I can say that the number of, let's see, a small restaurant customers served per hour, okay? On the day they served 10 customers per hour, that was 40% of the days, basically, 0.4. So what's the probability of getting 12? 0.2. A 10 or a 4, 14, we just put those together. 0.4 and 0.1, that's 5. And I would strongly recommend that you go ahead and write 0.4 plus 0.1 and don't skip to the 0.5. Okay, I have seen questions where you did not get full credit on something as simple as this for not showing the addition of the two parts. It's annoying but true. Write it all down. At least 11. At least 11 would include 11. So I want everything 0.2, 0.2, 0.1, 0.1. I'm going to add those together and get 0.6. You could also say that's everything except for 10. So you could do 1 minus 0.4 as your work. Okay. All right, next question says, are the following disjoint? So if the following are disjoint, so I look at these two questions and I ask myself, disjoint means mutually exclusive. That means the probability of A and B is 0. So notice these aren't mathematical. So how would you reason through this? So I have two events, being late and exceeding the speed limit. And I would say, could those things overlap? Absolutely. Now, there are some people who are just late and they're just going to drive at a regular speed. And there are some people that are exceeding the limit just because they can't help themselves. And there are other people who are late and doing that. In fact, I would say it often occurs that when people are running late, they may exceed the speed limit. So that would be a no, not disjoint, because they often happen simultaneously. Okay, passing the test and failing the test, however, those would be disjoint. So are they disjoint? Yes. These are mutually exclusive because you can't pass and fail the same test due to the definitions of those words. All right, so this is just a quick notes walkthrough. If you have any questions, please make sure you email me. This should be a review of a lot of things you've talked about in previous math courses. Okay, it shouldn't be anything new here, but I do know that we had to cut semester 2 last year short. So some of your probability reviews in your algebra classes and pre-calculus classes may have gotten cut down a little bit. Okay, so make sure if you have any questions, let me know. And good luck.